Welcome back to the Deep Dive. Glad you could join us.
Great to be here.
Today, we're really cracking open the tech sheet on a serious piece of production hardware.
We are indeed. It's the Bluefish444 EB3005CGF Epoch Supernova CG. Quite a name.
Haha, yeah, definitely a mouthful. But look, if you're working at the sharp end of broadcast or high-end post, this is the kind of gear you need to know about.
Absolutely. We're talking broadcast graphics, post-production, live events, DI.
Mobile production, QC, video over IP, streaming. It covers a lot of ground.
Basically, anywhere that needs top-tier performance and rock-solid reliability. High-stakes stuff.
And where super low latency isn't just nice to have, it's, well, essential.
Exactly. That's the core requirement here.
Okay, let's jump right in. The immediate thing you see are those connectors. 4 BNCs.
Right. 4 independent HDSD SDI BNCs. And crucially, they're bidirectional.
Bidirectional and simultaneous, so 4 streams in or out or mixed.
Yep, all at the same time. That flexibility plus that extremely low latency, we're talking subfield or subframe.
Which is incredibly fast.
It makes it real-time powerhouse. It can handle up to DCI 2K resolution at 30 frames per second for both input and output.
Okay, 2K30. And that resolution needs dual-link HDSDI, right?
That's correct, yes, for the full 2K30 bandwidth.
Now, doesn't that, make things a bit more complex, more cables, especially in, say, a fly pack setup? Is that a trade-off people just accept?
It is, yeah. You trade a bit of cabling complexity for guaranteed performance.
Ah, okay.
With dual link, you get that absolutely solid sync and the low latency you need for live graphics or critical monitoring. It's really a reliability choice.
Got it. Reliability first. So the physical I/O is robust. What about what's happening inside the card? How does it ensure image quality?
Good question. That comes down to the internal processing. It uses a full 12-bit video signal path.
12-bit all the way through.
Yes, 12-bit processing.
Yeah.
This gives you, especially colorists, that extra headroom for, say, HDR workflows or complex digital intermediate work. It's about precision.
And there's a specific component mentioned for color fidelity, a 4 by 4 by 33-bit color matrix.
That's right. It sounds very specific, doesn't it?
It really does. What does that actually do for you in practice?
Well, it means the card can handle very, very fine-grained color space conversions in real time. Think moving between different broadcast standards or color spaces without getting those nasty color shifts or banding.
Ah, so it maintains color accuracy across different formats on the fly.
Exactly. Guarantees that fidelity you'd expect.
And it's not just processing. There are dedicated hardware tools baked in too, right? Like the hardware downstream keyer, HDK.
Yes, the HDK.
Yeah.
Having that function like overlaying titles or graphics handled directly in hardware is key.
Why hardware specifically? Couldn't software do it?
Software could, but hardware is faster and more reliable for this. It avoids hitting the main CPU, which keeps the overall system latency low and consistent. Critical for live keying.
Makes sense. Keep the pipeline flowing smoothly.
And you also get that dedicated BNC reference input for Genlock, essential for syncing everything up perfectly in a broadcast environment.
Okay, let's talk system integration. It's a PCIe card, full height, 2/3 length, but it's a 4-lane PCIe Gen 1 card.
Yes, 4 lanes Gen 1.
In a world where we're seeing Gen 4, Gen 5,
Yeah.
even Gen 6 on the horizon, isn't Gen 1 a bit dated? A bottleneck?
You might think so initially, but it's actually a very deliberate design choice.
No. How, Sarah?
This card prioritizes reliability and proven stability over raw theoretical bandwidth. PCIe Gen 1x4 provides plenty of bandwidth for DCI 2K30 signals, especially with its full duplex DMA data transfer.
DMA, direct memory access, so it moves data efficiently without bogging down the CPU.
Precisely. Using a mature standard like Gen 1 maximizes stability, reduces driver compatibility issues, things you absolutely cannot afford in mission-critical live situations.
Okay, that's a really interesting perspective. It's consistency over bleeding-edge speed.
That's the philosophy, yes. And it works across platforms, too. Mac, Windows, Linux.
Which is great for flexibility. I also saw it mentioned you can use optional Thunderbolt enclosures like from Sonnet.
You can. That opens up some really interesting workflow possibilities, especially for mobile setups. You can put this card in an enclosure.
And maybe put another PCIe card next to it, like a fast SSD or something?
Exactly. You could build a pretty powerful portable I/O and storage hub. And they haven't forgotten audio either. It handles 16 channels of embedded SDI audio.
16 channels embedded and Dolby Digital Pass-Through.
Yep, supports Dolby Digital Pass-Through on the SDI stream.
Plus, for people building custom solutions, it comes with software.
That's right. You get a free download of their InstaStore software for acquisition, and importantly, the cross-platform SDK, the software development kit.
So you can integrate it deeply into your own tools.
Correct.
And finally, the practicals. Is it available? What's the damage?
Sources say it's currently listed as in stock. The price point is around $2,895.
Okay, almost $3,000, which, for this level of specialized hardware, seems about right.
It's definitely professional grade kit.
So wrapping this up, the bottom line for you, the listener, seems to be this. The Epoch Supernova CG is about robust, professional I/O, 4 bidirectional SDI ports,
Combined with that high-fidelity 12-bit internal processing and the hardware gear.
all prioritized for maximum reliability and demanding real-time broadcast and streaming tasks, maybe sacrificing peak theoretical speed for that stability.
Absolutely. The whole architecture, even the 256 MB of onboard memory, points towards consistency.
Which leads to a final thought, maybe a provocative one.
Go on.
Given its design, particularly that choice of PCIe Gen 1 for stability, it makes you really consider, when building a critical system, are you better off chasing the absolute latest, fastest interface for, say, huge 8K file transfers?
Or investing in a proven, mature architecture like this that absolutely guarantees every single frame gets processed and delivered exactly when it needs to, especially in a live context. It's that choice, isn't it? Throughput versus certainty. Something to think about.